to learn how to configure and consume a RHODA connected database inside a Jupyter Notebook. And why would you want to do that? Why would you want to integrate RHODA connected databases and Jupyter Notebooks? Integrating your Jupyter Notebook with services that are offered inside of Openshift allows your data scientists to take advantage of the larger Openshift environment without having to know all of the details. In previous videos, we've already shown how developers can self-serve database credentials via RHODA, and this video extends on that idea, bringing RHODA connected databases into your Jupyter Notebook. Let's get started. This process simply involves manually creating a service binding between a notebook and a DBAS connection. The commands you are viewing will help you verify that your setup is ready. We are on a managed Openshift cluster, in this case RHODA, and we've installed and configured Kubeflow's notebook controller. And of course, RHODA is installed. That is, the Red Hat OpenShift Database Access add-on is installed, and the inventory, that is DBAS inventory, has already been populated for you. Here's how we create the service binding manually. Step 1, switch to your notebook's namespace. By default, Notebook Controller uses Kubeflow User, but yours might be different. Step 2, check our running notebooks and decide which notebook you want to use in your service binding. I'm going to use mid998. Step 3 is check for connected databases. This is AKA DBAS connections, and decide which one you want to use. Step 4, quick check on our current service bindings. And don't forget to copy the name of the DBAS connection you want to use, because we're going to need it in the next step. Step 5, create the YAML for our service binding. The YAML for our service binding is really straightforward. Under spec, we have only two small parts, application and DBAS connection. As you can see, the resource is notebooks, but a service binding should work with anything that is pod spec compliant. For this demo, I'm going to use mid998 notebook and the RHODA TestCrunchy DBAS connection. Step 6, we apply the service binding YAML. And step 7, finally, we check the service binding status, which should be ready is true and reason is application bound. And that's it. That's how you integrate RHODA with your notebook. Now I'm going to hand this over to my data scientist to show you how to consume RHODA from within a notebook. Thanks for watching.
Hi everyone. My IT operations has already added the cloud-hosted database instances in my OpenShift namespace where I'm developing the data science application. The service binding to my Jupyter Notebook pod has been created with the database instances I'm going to be using in my development. As you may know, service binding for Kubernetes standardizes exposing credentials like user login, password needed by applications to connect to backing services like databases. Let's start with the notebook where we will access MongoDB Atlas database. Now, before we start writing code in our Jupyter Notebook, we need to do a one-time install of a few libraries that are needed for accessing the database. We can start with the Kubernetes service binding library for Python called PyServiceBinding. PyMongo is a Python distribution containing tools for working with MongoDB and is the recommended way to work with MongoDB from Python. Next, we are going to check if the Jupyter Notebook pod has a service binding, which is indicated by the presence of an environment variable called service binding root. If we get an OK, that means a service binding exists to the pod running the Jupyter Notebook. Now we can use the PyBinding service library to specifically get the credentials needed to connect to a database of type MongoDB, and the provider is MongoDB Atlas. If successful, we get a non-empty list, and we can construct the connection string with the return credentials. Then we connect to the database instance and get a client handle. Here is a code snippet where I'm using the client handle to search for a MongoDB collection called fruit. We open another notebook using the file new notebook, and this automatically inherits the service binding that has been projected into the pod. To save time, let's jump to the cockroach notebook. Now in this notebook, I will show you how to connect to a PostgreSQL database instance provided by Cockroach DB Cloud. We'll be using the verify full SSL mode to verify the identity of the Cockroach DB node. Also in this mode, the data in flight is encrypted, ensuring a secure connection to your cluster. The libraries you need are PyServiceBinding like before, and PsychoPG, which is the most popular PostgreSQL database library for Python. Next, as before, we will confirm that the injected service binding is detectable and we get an OK. Now we use the PyBinding service library to specifically get the credentials needed to connect to a database of type PostgreSQL, and the provider is CockroachDB Cloud. If you're successful, we get a non-empty list. We will connect to the database using the return credentials. Notice that there are additional parameters here for the secure SSL mode. In this cell, we will use a database connection to execute a SQL query on a database table called accounts. Now, there are different ways to basically ingest results from the SQL query into a pandas data frame. I'm using the database connection fetch all API. And finally, let us open another notebook instance and connect to a Postgres database instance that is hosted by the Crunchy Bridge cloud. The steps and the library dependencies are the same as in the previous examples. In this case, we will read a car Blue Book dataset from Postgres database and use the scikit-learn feature selection library to determine a handful of features from the list of features like make, model, mileage, etc. We'll find out what features are most important determining the price of a used car. Now, all these notebooks are available on GitHub, listed below. Thank you.